Hey everybody, and welcome back to another video. In the previous episode, we had set up a very basic animal script, which allowed animals to wander around the scene and enter an idle state. In today's episode, we're going to be creating a predator and prey script that will inherit our animal script and improve upon it, allowing us to have different behaviors for different types of animals. There's one important thing I'd like to note, and that is to all your animals, you will need to be adding a box collider. This will allow it to be detected by our predators and prey, and it's something I left out of the previous video. I'm going to go ahead and cut to another scene where we last left off, and I will walk you through creating this new system. So let's go ahead and jump into our animal script, and there's a few modifications that we need to do here, so let's open this up. So here we are in our animal script, and the very first thing that we want to do is privatize all of our current variables. So the way we're going to do this to allow us to still access it from our inspector is we're going to do two square brackets, and inside of this we're going to write serialize field like so, and we're going to write private. So now we have serialized field, private float wander distance, and then we're just going to copy and paste this and double click on all of our publics and Control V, just like so. The reason for this is because we want to encapsulate all of our variables within our class, allowing no other scripts to access these unless they are inheriting from the animal, in which case they will be able to. Beneath our idle, we're going to add a new header, and this is going to be for our chase. This means different things for both the predator and the prey. So for the predator, this will mean how fast it chases the animal, and for our prey, it will be how fast it runs away from predators. So bringing in our serialized field again, we're just going to write private float run speed, and we're going to default this to be something a little bit higher than our walk speed. I think our walk speed is 5, so we'll set our run speed to be about 8. Then once again, we're going to create another header, and this is going to be our attributes header, which is going to hold stuff like species name, health, stuff like that. And now we're just going to be doing our health. So again, serialized field, private int, and this is health, and we're going to default this to be maybe 10. So now we're going to be adding a new state to our animal, which is going to be called chase. So coming on to your animal state, just write chase here, just like the others. And then scrolling down, we're going to create a new case. So I'm just going to copy and paste this one. Case animal state and replace moving with chase. And then we're just going to type in here, handle chase state. We're then going to scroll down to where we're handling our other states. I'm going to do mine just above the handle idle state. And I'm going to type in protected void or protected virtual void handle chase state, just like so. So our handle chase state is going to be overridden within our predator and prey, so we don't need to worry about this yet. All we're going to do in here is just type in stop all coroutines, and this will just pause any movement or idle functions that we are currently running, so that we can then straight away enter our chase state. We're then also going to create, just above this, another protected virtual void, and we're going to call this our check chase conditions. This will have nothing in it at all because we are going to be controlling this within our predator and prey scripts that we're about to create. So you can leave this empty for now. The only thing you're going to want to do is come down here to your wait to reach destination function, and you're going to type in check chase conditions. This means that when our predators are moving around, they'll be constantly searching for prey to chase. They will only do this when they're moving. When they're idle, they will just ignore all prey. So one minor change that we want to do in our wait to reach destination function, which I forgot to do in the previous episode, is type here navmesh agent path pending, like so. And then between these, we're just going to add 2 vertical bars. The vertical bars essentially act as an or statement. And the reason for this is because there was a minor bug where the navmesh agent hadn't actually decided on a location to go to yet, which would make it think that it had already reached its location, causing the animal to go directly to its idle state. Now we're waiting for the path to actually be created before we then wait to reach that destination. At the end of this, we're also just going to do and just do navmesh agent dot is active and enabled. And this will just be a quick check because we're about to create a death function within our script. And this is just to help remove any potential errors that might occur if we were to kill an animal and destroy its object. The nav mesh would no longer exist. So now we're going to come down to our onStateChanged function, and we're just going to go in here like so, and we're just going to type in if new state is equal to animal state moving, then we are going to set the navmesh agent's speed, so navmesh agent.speed to walking speed, like so. Zoom in a little bit here. Then beneath this, we're just going to do if new state equals animal state dot chase. We're going to set our navmesh agents dot speed to be equal to chase or run speed, like so. So this just means that when the animal is being chased or chasing, it will run, and when the animal is wandering around and just moving casually, it will walk. Beneath this, we are going to create two new functions. So the first one is a public virtual void, and this is going to be called receive damage. And we're just to this going to pass in an int called damage. Then we're just going to do health minus equals damage and do a quick check. So if health is smaller or equal to 0, we're going to call a new function called die. This just means if the health has gone below 0, our animal has died. And finally, we're going to create a protected virtual void down here and call this die. And within this, we're going to call stop all coroutines and finally destroy and game object. There's one final change that I want to make within this animal script. Currently, the get random navmesh position is recursive, meaning that if we can't find a valid position, we just try again and again and again and again and again until we do get a valid position. This works if there's a guaranteed chance that at some point the animal will receive a valid position. But let's say, for example, there are no valid positions for the animal to move to. This would cause a stack overflow error, where the computer keeps trying to find a valid position, just goes and goes and goes and goes and goes, and then eventually we get this stack overflow, meaning that we've made too many requests and there's no more space to store the data. To fix this, what we're going to do is replace our recursion with a loop. So to do this, we're going to come above the top of our function, and we're just going to type in for int I equals 0, colon I is smaller than, and then this will be our max number of attempts we can create. So I'll type something like 5, colon I plus plus, and then we're going to open this up. You're going to want to copy these lines here, so your vector3 random direction, your random direction plus equals origin, your navmesh hit, and your first if statement, and paste this in like so. You're then going to delete this else, and in place of that, you're just going to type in return origin. Essentially what this means is if we can't find a valid position to move to within 5 tries, we will just return the original point of the animal. So that just about wraps up everything we need to do within our animal script. We're now going to go back to our Unity scene, and we're going to create two new scripts, one called prey and one called predator. So we're going to start with our prey script here. So just create a new script and call it prey. And we're going to pop this open as soon as it's loaded. So once we're in our prey script, the first thing we're going to want to do is set up some variables. So coming into the top here, we're just going to create a brand new header, and we're going to call this our prey variables, like so. Then we're going to type serialized field, private float, and we're going to call this detection range, and default this to be about 10. Beneath this, we're going to do again serialized field and private float, and we're going to call this our escape max distance, and we're going to default this to be maybe 100 or something like 80. Finally, we're just going to create a private predator. This is going to give us a red squiggly line because there's no predator script yet, and we're just going to type in current predator is equal to null. So to fix this squiggly line, we obviously need to come back to our Unity scene, and we're going to create a brand new script and just call this predator, like so. And then we can just pop that open if you want to, or you can wait. We're not going to touch this until we're finished with our prey script. Coming back to our prey script, you can now see that predator is being picked up as a class, and you're no longer getting that squiggly line. Beneath this, we're going to create a public void, and we're going to call this alert prey. This function will be called from our predator script. So we're also going to pass in a predator and then just type predator again. This is going to let our prey know that it's being chased. So the first thing we're going to do, oh, I forgot. Coming up into the top of the class, you'll want to change mono behavior to be animal. This is going to inherit the functions and variables from our animal script. Now we should be able to call set state. Yeah, now we can. So we're going to type in set state, animal state, chase. So now our prey is in its chase state. We're also going to want to type in current predator is equal to predator, which is the variable we've just passed in. And we're going to do a start coroutine, and we're going to call this run from predator. Like so. Beneath this, we're going to create a private IE enumerator. And of course, this is our run from predator function. So there you go. And within this, we're just going to do a yield return null for now to get rid of that squiggly line. We'll fill this in just a moment. There are a couple more things that we're going to want to do before this, which is create a private void. And this is our run away from predator function. Beneath this, we're going to do a protected override void. And this is our die function. And as you can see, it will autofill with base.die. So essentially what this is doing is it's overriding the die function within our animal. And as you can see in our die function, we stop all the coroutines and destroy the game object. But within this, there are separate coroutines that we won't be able to stop from our animal script. So we override this void and also call stop all coroutines within this function. And this will stop this run from predator coroutine. Beneath this, there's one last thing, which is going to be a private void on draw gizmos, and this is going to allow us to visualize the detection range of our prey in the scene view. So we're going to do gizmos.color equals color.green, and then we're going to do gizmos.draw wiresphere, open our brackets, type in transform.position for our center, and for our radius it will be the detection range. You can actually copy and paste this function because we're going to need it in our predator as well. So just throw that at the end of your predator. And within this, we're just going to make this a red. So coming to our run away from predator function, we're going to just set this up. So if navmesh agent doesn't equals null, like so, and navmesh agent dot is active and enabled so that we haven't died. That's just a little check. We're then going to do a separate if, and if exclamation mark navmesh agent dot path pending and navmesh agent dot remaining distance is smaller than navmesh agent dot stopping distance, and then we'll open this up. So what this function is actually going to do is determine if we have a destination to move towards away from the predator, and if we don't, we will create a destination to move towards and tell the navmesh agent to move there. This will give our prey a fighting chance against the predator, as all it can do is run away. The way that we're going to do this is type vector3, and then we're going to do run direction, and we're going to equal this to transform.position minus current predator.transform.position. Just like so. We're going to need this. We're going to create a second vector3, and this one is going to be called escape destination, and equal this to transform.position plus run direction.normalize times, and then we're opening some brackets, and we're going to call this escape max distance and times this by 2. Finally, we're going to do navmesh agent dot set destination, and then open this up, and we're going to do get random navmesh position, open this up again, escape destination, comma escape max distance. So in a poor attempt to actually explain what this function is doing, you can imagine this red ball as our predator and this blue ball as our prey. Instead of passing in the blue ball's actual position or our prey's actual position, we are instead passing in an offsetted position over here, so that when we randomly get a point to move to, it will be further away. If we passed in the prey's actual position, it might choose to then move over here, which would just look a bit awkward. So instead, we are limited to sort of this circle, and it will always move away from the predator. Okay, so now we're going to move on to our run from predator function. So you can imagine this to be split into 3 separate stages. So coming up here, beneath this comment, we're just going to type in while, and then we're going to type in current predator null, 2 vertical bars, and then vector3 dot distance, transform dot position, comma, current predator dot transform dot position. And then at the end here, we're going to do a greater than symbol and type in detection range. So this is essentially checking to see if our predator is within our detectable range of the prey. And if it isn't, we're just going to type in yield return null. So again, we're going to type in while current predator doesn't equals null. So now we do have a predator to run away from. Instead of vertical bars here, we're doing and. Then we're going to type in vector3.distance again, and we can actually just copy and paste this because we're going to need it anyway. So vector3.distance, open bracket, transform.position, comma, current predator.transform.position. And currently this symbol is checking to see if the distance is greater than our detection range, but now it is within our detection range. We want to see if it's exited our detection range. So we're going to do a smaller than equals detection range. So we're going to type in here, run away from predator, open bracket, close, just like so. And then beneath this, we're typing in yield return null. So this means that while we are being chased by a predator, we will run away, obviously. And one final section here at the very bottom is the predator is out of range, and we can run to our final location and go back to our idle and wandering states. So to do this, we're just going to do if exclamation mark navmesh agent dot path pending and navmesh agent dot remaining distance is greater than our navmesh agent dot stopping distance, like so. This is very similar to other sections of code that we have. It just means that while we haven't reached our destination, we should just continue to wander towards that. So here again, we will just do yield return null. At the very end of this, we're then going to go set state, animal state, dot idle. And that just about wraps everything up for our prey section here. We're now going to move on to our predator section and now going to set up the chasing and detection of prey. So now we're in our predator script. The first thing we're going to do is delete these void starts and updates, and we're going to set up some variables. So again, we're doing a new header here, and inside of this, we're going to type in predator variables. Beneath this, we're going to serialize field, private float, and we're going to call this detection range, and equal this to be a little bit larger than our prey's detection range. As you can see, our prey's detection range is around 10, so we're going to do maybe 10 or 15. Again, we're going to do serialize field, private float, max chase time. So this is how long our predator can actually chase prey before it gets too tired. Then again, serialize field, private int, and we're going to call this our bite damage and default this to be maybe 3. And one last time, serialize field, private float, and this is going to be a bite cooldown, so how often our predator can bite an animal. And we'll make this maybe 1, like so. Finally, we're going to do a private prey and call this our current chase target. Right beneath this, we're going to go ahead and create a new protected override void, and we're going to call this our check chase conditions. You're going to notice that we are again getting this reddish green line, and it is because I forgot to put animal instead of mono behavior again. So now we're overriding this check chasing conditions function from within our animal. And as you can see, this check chasing conditions function is being called when we're moving around. So this function will call this function, and because it's being overridden in our predator, it will actually call the predator's function first. So within this, we're just going to do if current chase target. I'm just going to return. This means that we already have a target that we're chasing, so we don't need to check our chase conditions. Beneath this, what we're going to do is type in collider, square brackets, colliders is equal to new colliders, square brackets again, and then we're going to type in 10. Beneath this again, we're going to type in int num colliders, and then equal this to be physics.overlap sphere non-alloc or non-allocated, and we're going to type in transform.position, and for our radius detection range, and finally we're going to type colliders, like so. So what this is essentially doing is we are going to create a sphere around our predator, and it will detect all the colliders within our sphere. Then we're going to check those colliders to see if they are predator or prey. Beneath this, we're then going to do a for int I equals 0. Then we're going to do I smaller than num colliders, finally I++, to loop through all of our colliders that we've detected. We're then just going to do prey is equal to colliders square bracket I dot get component, typing in prey here to try and get the prey script off of any collisioned objects. If we can get a prey script off it, it means it's a chaseable animal. So we're going to just do type if prey doesn't equals null. So if prey has actually been found on this object that we're looking at, we're then going to do a new function that we haven't created yet called start chase, and we're going to pass in our prey, and then finally we're going to return out of this void. Now beneath our entire loop, meaning if we get to this point that we haven't found any prey to chase, we're just going to do current chase target is equal to null. Now we're going to create our start chase function. So coming beneath this, we're going to type private void start chase, and to this we're passing in a prey, and we'll call it prey like so. We're just going to do current chase target equal to prey, and then set our state to animal state dot chase like so. That's all that needs to go in this function. So beneath this, we are then going to create a protected override void, and we're going to call this a handle chase state. So again, you're going to see base.handle chase state pop up. You're going to want to keep this, but above this, what you're going to type is if current chase target doesn't equals null, and open this up. We're going to do current chase target dot alert prey, and then we're going to type in this. This will alert the prey that is currently being chased by a predator. Then we're going to do start coroutine, and this is again another function we haven't created, which is called start prey, or chase prey, sorry. Beneath this, you're then going to want to create an else, and this basically means if there's no animal that we can actually chase, there's no valid target, we'll just go back to our idle state. So set state, open bracket, animal state dot idle, like so. So coming beneath this, we're going to create a private IEnumerator, and this is going to be our chase prey coroutine. And the very first thing you're going to want to do is type float start time is equal to time dot time. This is going to record the time that we started our chase, and if we exceed that amount of time, meaning our predator has, or rather our prey has managed to escape our predator, the predator will stop chasing this animal. Within this, you're going to want to do a while. We're going to type in current chase target doesn't equals null, and vector3 dot distance open bracket transform dot position comma current chase target dot transform dot position. And coming out of this first set of brackets here, we're just going to do a greater than symbol and Navmesh agent dot stopping distance. So what this is doing here is making sure that our prey that we are chasing is actually still exists. It hasn't been eaten by another predator, and that the distance between the predator and the prey is not small enough for the predator to take a bite out of the prey. So within this, what we're doing is we're doing our countdown. So we're going to do if time.time minus start time is greater or equal than max chase time. And then we're doing an OR, so two vertical bars, current chase target equals null, meaning that we have either exceeded our max chase time or the target has been eaten. We're just going to call a stop chase function, which again we will create in a moment, and then we will type in yield break to break out of this coroutine. Now beneath this if, we're then going to type in set state animal state dot chase, just to double check that we're in our chase still. Then we're doing a Navmesh agent dot set destination, open this up, current chase target dot transform dot position, meaning that our predator will start to run towards the prey that we are chasing. Finally, beneath this, you're going to want to type in yield return null to ensure that we continue to chase our target until we either reach it or we time out and have to take a break. Then we're going to come beneath this and just type in if current chase target. Then we're going to do current chase target dot receive damage and type bite damage within that. So this essentially means if we did get close enough to our prey, we can take a bite out of it. The prey will receive the damage, it will check if it's died, and if it has died, then it will destroy itself. Otherwise, it hasn't died. We're going to do a yield return new, wait for seconds, and we're going to type in bite cooldown. And beneath this, you're then going to do current chase target equals null and handle chase state. Then at the very, very bottom here, we're going to do a check chase conditions again. So essentially what this is now doing is we are taking a bite out of our prey. We're then going to wait for our bite cooldown to time out. When it has timed out, we are then going to reset our target, handle our chase state, which was up here, and then we're going to recheck to see if the prey is still within our range to continue chasing it. You're going to want your bite cooldown to be something quite low, like 1 or 0.5, because it will pause in this moment between that. This will allow the prey a little bit of time to actually move away from the predator. So now the very last thing we're going to want to do here is create our stop chase function, which is currently red squiggly lined. So this is going to be a private void, stop chase, open bracket, and within this you're going to type navmesh agent.reset path, so we're no longer chasing. Then you're going to do current chase target is equal to null, equal to null, like so, and then finally set state, animal state, idle. And that just about wraps everything up within our prey and predator scripts. We can now go back to our scene and get the rest of this set up. So now here we are back in our scene. As you can see, our sheep still has this animal script connected to it. So what we're going to do is remove this, and we're going to pull in our prey script to replace the animal script. As soon as you do that, you'll notice this detection range bubble pop up around it. You can edit your detection range, and this will edit that sphere. Another thing you'll notice is that all of our variables from our animal script are still visible and still editable. There's nothing I really want to change here, but obviously you guys can play around with this as much as you want. I'm going to go ahead and create a predator. So our predator here, remove the prey script. We're going to make this a fox, and we're going to add our predator script. And to this, I'm just going to add a new material and call this red, just to represent that this is the enemy or the predator. There you go. Now we have our prey, which is just a little sheep, and our fox, obviously a great looking fox. There are, again, the predator variables now within this with a detection range, which you can edit once again. A max chase time, which I'm going to set to be maybe 20 seconds just for this example. Our bite damage, which is 3, and our cooldown. I'm going to make our bite damage 4 for this example. One last thing I'm going to do to our fox here is give it a faster run speed than our sheep. This will allow it to catch up and actually kill the sheep for this example. As you can see, we've started the game. Our Navmesh agents have connected to the fore, and our sheep is now being chased by the fox. The fox has taken a bite. It's going again. As you can see, our health has gone down. It's taking a second bite here, and it has actually managed to kill the sheep. That just about wraps it up for today's episode. It's been a bit of a long one, so I hope you have enjoyed, and thank you so much for watching.